Today we are going to discuss about the cryptography, which is the concepts and the techniques related with the cryptography. First of all, what is cryptography? So cryptography, as you know, it's a kind of a technique by which uh, we are trying to secure, we are trying to hide the messages from those persons who are not required for that. The messages are meant for legitimate receivers only. So we are in need of certain technique by which we can hide, we can secure our message so that it cannot be read and understood by each and everyone who is present in the network and trying to find out. So with the help of this cryptography, which is an art as well as the science of achieving the security, uh, and how it can be done, it is done by encoding the message so that uh, uh, no one will be able to read it. Even one is able to read it but unable to understand it because it is in the encoded form. So you can define the cryptography as a art as well as the science for achieving the security of the messages which is being transacted in between the sender and the receiver. Now, the second part is cryptanalysis. Cryptanalysis is a kind of technique of encoding the message from the non-readable format back to the readable format without knowing the method by which it has been converted. Of course, there are many methods in the cryptography by which we can encode the message. And if there is a process by which we are encoding the message, there is a process by which we are going to decode the message. So cryptanalysis is a kind of is a technique without knowing that how it has been encoded, and if we want to find out the non-readable message back to the readable message without knowing the method of conversion by using hit and trial method, that process, that technique is called cryptanalysis. And cryptology is a combination of the cryptography as well as the cryptanalysis. So we should be very clear about that. What is the meaning of a term cryptography, which is a technique by which we are converting, we are encoding the messages as well as decoding the messages. Cryptanalysis is a technique of converting non-readable message back to the readable message without knowing that how it has been done, which method has been adopted, and cryptology combines all these three techniques. Now, in this cryptography, we will be using this plain text very often. Every time we will be using plain text. Plain text is a kind of a text which is called the clear text, the text which can be easily understood by the person who is going to read that one. So that is called plain text. And the plain text normally is used in the language which we normally use, and it is easily understood by each and everyone. This is a kind of a plain text. This is an example of a plain text in which a person is writing a letter to somebody else, in which everything, whatever is written, it is readable as well as it is understandable. What the message is saying, what is want to communicate through this message, it is able to understand. So this type of messages are called plain text message. Now, normally, what we used to do, we don't send this kind of messages whenever we want to hide the message from the rest of the person, and this message is meant only for the legitimate user. So we will be using certain kind of the technique by which we are encoding the messages, and the first method which is used for encoding the message is called the Caesar cipher. It was invented by the Caesar very long back in the 18th century, and what this Caesar cipher says. Before we are going to give you the idea of Caesar cipher, Caesar is the name of the person who has invented it, and the cipher means the text message which is not plain text, which is unreadable text. So that type of text is called cipher or the cipher text. So that is why the name Caesar cipher has been given. Now, Caesar cipher is a mechanism to make a message non-understandable by encoding using a certain process which has been given by the Caesar. Now, what it used to do, it replaces each alphabets with 3 places down. And for example, that if we want to replace A will be replaced by D, 3 character down the place, it means A will be replaced by B, C, D. B will be replaced by E, and so on. So this is the process how the Caesar cipher used to do. A is replaced by D, B is replaced by E, C is replaced by F, D is replaced by G, E is replaced by H, and so on. So this is a very simple process which is known as Caesar cipher method, by which we are encoding the plain text into a ciphertext. So if we want to use the Caesar cipher to hide a message, suppose our message is yes, Y-E-S. If yes message is traveling in a plain text form, everybody will be able to know that what is the meaning of that communication. Yes means yes. But instead of yes, if we are using Caesar cipher, so Y will be replaced by B, E will be replaced by H, and S will be replaced by V. So the text will become, instead of YES, we will be sending B, H, and V, BHV. Now, if instead of yes, BHV is traveling, so it is not understandable by the person. So that is the meaning of, that is the method of doing the encoding a plain text matter into a ciphertext method. And this method is known as Caesar cipher method. So let us have an idea that what is called plain text and what is called the ciphertext. Of course, whenever we are encoding plain text into unreadable form, that is called ciphertext. Whenever decoding the ciphertext to understand that what message is, it is called plain text. So the plain text is the language that can be easily understood, and ciphertext is using a language that cannot be understood. And to achieve the security, plain text is transformed or converted into a ciphertext. So this is an example of a plain text and the ciphertext using the Caesar cipher method, in which one place it is the plain text message and another is the corresponding ciphertext message, by converting each and every character 3 character down and replacing each character by another character. So this is an example of a plain text and this is an example of a ciphertext. So if this plain text is traveling, everybody is able to understand that what does it mean. But if this message is traveling, then this message is not understandable. So that is why it is necessary to, if you want to hide the message, it is necessary to convert the plain text into ciphertext. And whenever it is being received by a receiver, ciphertext is again converted into the plain text. Of course, the method which are used for the conversion of plain text into the ciphertext, the reverse method will be used for converting the ciphertext back to the plain text. Now we have many techniques by which we can convert the plain text into the ciphertext. And there are 2 basic techniques. One is called substitution techniques and another is called transposition techniques. Substitution technique is a kind of a technique in which we are going to replace one character, one alphabet by another alphabet. So that is why it is called substitution. It means we are substituting any other alphabet in place of the alphabet which is available in the plain text. So whenever we are going to substitute, replace the particular character or particular alphabet by another alphabet or another character, that is called the substitution method or the substitution techniques. Transposition technique is a little bit different. It is also called permutation technique, in which in transposition technique, whatever message we are having, we change the position of the individual character or the individual alphabets so that the message will become unreadable. So what is the difference between substitution technique and the transposition technique? The difference is that the substitution techniques will be using the replacement of character from outside character. But transposition technique includes all those characters will be replacing each character, but the characters will be of the message itself. It is being transposed, it is being permutated. The position of the individual alphabet or the character is being changed so that it will become unreadable. And when both these two approaches are used, including the substitution method as well as the transposition method, that kind of technique is known as product cipher technique or the product cipher. So we have many methods in the substitution techniques, and we have many methods in the transposition techniques. We will be handling the individual methods one by one. First of all, I will be giving you the idea of the substitution technique. Caesar cipher, which has been discussed just before this slide. Caesar cipher is an example of a substitution technique in which we are converting, we are exchanging, we are changing the individual alphabet by three down the line by the another alphabet, as A is being replaced by D, B is replaced by E, and so on. Now substitution, let us discuss about the substitution technique. The first method is the substitution technique is the modified Caesar cipher method. In this modified Caesar cipher, instead of replacing the alphabet three places down the line, any places down the line can be done. Caesar cipher says that you can replace individual alphabet or the character three places down the line. But in modified, because that is very easy method. If anybody is able to know that the particular person has encoded his message by use of Caesar cipher method, and he also know that Caesar cipher method says that encoding, what you have to do, you have to change the character by three places down the line, replace the character by three places down the line. If one is able to encode, another is also able to decode, because whenever we are doing the encoding process with the Caesar cipher method, we are replacing the individual alphabet by three places down the line, and whenever we are decoding, we are replacing the individual alphabet three places up the total alphabets. If A is being replaced by D in encoding process, D will be replaced by A in the decoding process. So this is it was very easy method, and that method is not going to work for many years. Then the people come with the idea of the modified Caesar cipher, in which instead of replacing the character three places down the line, any places down the line can be done. But it is constant. If A is being replaced by Z, if A is being replaced by D, then B will be definitely replaced by E. Whatever down the line you fix, if you say that any character will be replaced by six places down the line, then every character will be replaced by six down the line. That is why it is called constant. That is why it is called constant. So how many possibilities are there? So there are 25 possibilities. So there are total 25 possibilities, because there are 26 characters, 26 alphabets in the English language, and we are using normally English language as the mode of communication. So the possibility is you can go one places down the line, two places down the line, three places down the line, four places down the line. So there are 25 possibilities. A can be replaced by Z, A can be replaced by W, A can be replaced by V, A can be replaced by L. But how many places you are going down the line, it is applicable for all the characters or the alphabets which are available in the plain text. So an attack on the ciphertext message wherein the attacker attempts to use all the permutations and the combinations. If any person is able to know the ciphertext, because ciphertext is really traveling on the network, and it will be able to be trapped by any person who is sitting in between. So what he will try the first possibility one down the line, he can try two down the line, three down the line, four down the line, five down the line, and so on. So he will be using the trial and error method. He will be using all the permutation and the combination. And this attempt, which he will be doing for getting the what possibility of the replacement has been done during the encoding process, it is called brute force attack. So brute force attack is nothing but it is a trial and error method in which the attacker is not able to know, is not knowing actually that how many places down the line has been used for the replacement. So what he will do, he will check all the possibilities. So that kind of attack is called brute force attack, without knowing that what is the modality which has been used. He will be using the trial and error method. So the process is called cryptanalysis. The person who is doing this brute force attack, trying to find out that what is the plain text from the ciphertext, and that process is called cryptanalysis because it is not known to the particular person. So that process is called cryptanalysis, and the person who is doing this will be called as a cryptanalyst. So since there is certain demerits of Caesar cipher, then we come with the modified Caesar cipher, and modified Caesar cipher is also not very safe, not very secure, because it can be brute force attack can find out that what kind of process has been adopted. So the second method in that substitution technique is the mono-alphabetic cipher. Now in mono-alphabetic cipher, there is a random substitution which is being done. Random substitution means if A is being replaced by 24 character down the line, it is not necessary that B will be replaced by 24 character down the line. Not so. That is why it is called random substitution method. If A is being replaced by 24 places down the line, there is a possibility that B will be replaced by 3 places down the line. C will be replaced by 10 places down the line. So this is random. That is why it is called random. And the name has been given as mono-alphabetic cipher. So what does it actually means? A can be replaced by any alphabet from B up to Z. Similarly, B can be replaced by any character from A or C or up to Z. So there is no fixed formula by that if A is replaced by 10 character down the line, it is not necessary that B will be replaced by 10 character down the line. So this method is better method than the modified Caesar cipher, because modified Caesar cipher was the better method than the Caesar cipher. But this mono-alphabetic is better than the modified Caesar cipher because it is going to pose a difficult problem for the cryptanalysis, because a high number of possibility, high number of permutation and combination he has to adopt for cracking that for cracking the plain text from the ciphertext. Because for A it has to go through 25 possibility, for B it has to go for 25 possibility, and so on. But in case of modified Caesar cipher, once possibility has been taken, for the rest of the character the same possibility will be there. So there are only 25 possibilities in the case of modified Caesar cipher. But in mono-alphabetic Caesar cipher, there are high number of possibilities which has to be done, which has to be taken care by the attacker. The third one is the homophonic substitution cipher. It is similar to the mono-alphabetic because the mono-alphabetic, later on it has been found that there are certain problems with the mono-alphabetic, and once a high-speed computer has been available in the market, and this to do the trial and error method to select an individual permutation and combination, the time will come when the mono-alphabetic cipher can be cracked. So people come with the idea of homophonic substitution cipher. Of course, it is similar to the mono-alphabetic, but in this particular case, one plain text alphabet can map more than one ciphertext alphabets. That is, A can be replaced by D, it can be replaced by H, it can be replaced by P, it can be replaced by R. So there is a particular set, and that set we have different alphabets, and any alphabet can be used to replace A. Suppose we have a text message, and in that text message A is being used 10 times. So if A is being used 10 times, so it is not necessary that everywhere A will be replaced by D. It may be possible that at one place A will be replaced by D, another A will be replaced by H. It may be possible that another A will be replaced by P or R, and so on. So what it involves, substitution of one plain text character with a ciphertext at a time. However, the ciphertext character can be any one of the chosen set. It can be D, H, P, R. Nobody knows. So this homophonic substitution cipher is little bit more difficult to crack in comparison to the mono-alphabetic cipher. So we have learned four methods: Caesar cipher, modified Caesar cipher, mono-alphabetic, and the homophonic. In Caesar cipher, 3 places down the line. In modified Caesar cipher, any places down the line. In mono-alphabetic, random substitution is being done. In homophonic, we have a certain set, and depending upon the condition, we can choose any character from the set to replace the individual character. The next one is the polygram substitution cipher. Now, polygram substitution cipher says that instead of substituting individual characters or individual alphabets, why not to make a block to block transfer? Because block of the plain text transform into a block of the ciphertext. Previous to polygram substitution cipher, whatever we have discussed, Caesar cipher, modified Caesar cipher, mono-alphabetic, as well as the homophonic, all will be replacing the character by character, alphabet by alphabet. But in this polygram substitution cipher, instead of replacing character by character or alphabet by an alphabet, what we are going to do, we are going to make block to block replacement. Block to block replacement, an example has been shown that if it is hello, it will be replaced by YUQQW. But if it is hell, it is not replaced by YUQQ, because hello doesn't means that H will be replaced by Y, or E will be replaced by U, or L will be replaced by Q. It is not so, because we are doing in polygram substitution cipher, for every individual word, for every individual text, we are replacing it by another text. So example has been shown that hello is replaced by YUQQW, but hell is replaced by TEUI. Now, if we compare the plain text hello and hell, there is only difference O, but you can see the difference in the ciphertext. So in polygram substitution cipher, we do block to block replacement. Then we have polyalphabetic substitution cipher. Next method is the polyalphabetic substitution cipher. In polyalphabetic substitution cipher, till now, whatever substitution cipher we have used as Caesar cipher, modified Caesar cipher, mono-alphabetic, homophonic, polygram, all these will be using simple the replacement either of the character or by the text, by text itself. Now, polyalphabetic substitution cipher is a little bit different from the previous 5 methods which we have discussed. Of course, it is being invented by Leon Battista, and it uses one character key. Now here the key has been introduced. It uses one character key, and each key encrypts one plain text character. First key will be used for the first character, and so on, and then it is recycled. Suppose, what is the meaning of the third point? Suppose we have a message, and in that message we have 10 characters, and we are using a key. Suppose we are using a key of 4 characters. So the first character of the plain text will be replaced by another character depending upon what is the first character of the key. The second character of the plain text will be replaced by another character depending upon the second character of the key. Third character of the plain text will be replaced by another character depending upon the third character of the key, and so on. And since I have told you that we have 10 characters in the message and there are 4 characters only in the key, so what we'll do, we are recycling the key. After the key will be exhausted, we will be using the next replacement by using the first character of the key again and again, and so on. And this polyalphabetic substitution cipher uses Vigenere Table. And what is that table? And depending on that, I am giving you the example that how this polyalphabetic substitution cipher is going to work. Now, this is the table which is given by Vigenere. That is why this table is known as Vigenere Table. Now, suppose the first character of the plain text is F. Suppose the first character of the plain text is F, and first character of the key is M. Then F will be replaced by which character? The junction of these two, that is R. So F will be replaced by R if the first character of the key is M. Suppose the second character of the plain text is just wait. Second character is suppose M. Suppose it is M. And the second character of the key is M also. So, second character of the key is also M. Then this M will be replaced by Y. If the second character of the key is U, then M will be replaced instead of Y, M will be replaced by M will be replaced by G. And so. So, using this Vigenere table, we will be substituting the individual character. However, it depends that what is the key character. So, key character is also going to play an important role in this substitution cipher, which is known as Polyalphabetic Substitution Cipher, which uses Vigenere table, which uses certain character as a key, and individual key will be replaced by another key. Individual alphabet will be replaced by another alphabet depending upon the key character. So this is the method which is called Polyalphabetic Substitution Cipher. Now the next one is the Playfair Cipher. Playfair Cipher has been invented by Playfair, that is why the name given as Playfair. Now this Playfair Cipher is using a matrix, and that matrix is also called Playfair square. Now two steps are used in this Playfair cipher. First is called the creation of the matrix. First of all, we create the matrix and then we adopt the encryption process. So how the matrix is being created? Of course, the matrix which will be created is 5 into 5, 5 cross 5. And in this matrix, the matrix which is being created 5 cross 5, it is used to store the keywords. It is used to store the keywords. Now, so before we are going to implement the Playfair cipher for the encryption process, we must have a keyword, and then we will start the process of adopting the Playfair cipher for converting the plain text into ciphertext. So how this matrix is being created? First of all, enter the keyword into a row-wise matrix, left to right, and from top to bottom. We used to drop the duplicate letters. Suppose the key characters which we are using as a keyword is having duplicate. Suppose A is being used twice, but we will drop the duplicate letters. Fill the remaining spaces in the matrix with the rest of the English alphabets from A to Z that were not a part of our keyword. And while doing so, combine I and J in the same cell of the table. In other words, I and J is the part of the keyword. Disregard both I and J while filling the remaining slots. So what does it actually mean? We have certain characters in the key. We have assumed that it is a keyword. And that keyword will not have all the 26 characters of the English alphabets. So, and we are creating a matrix of 5 cross 5. 5 cross 5 means 25 blocks will be there. And we have to accommodate 26 characters of the alphabet, English alphabet, into the 25. So that is why the third point is written. The third point says that I and J will be using the same block. I and J will be sharing the same block, and that is how we are trying to accommodate all the 26 characters within the 5 into 5 cross matrix. So सबसे पहले हम क्या करते हैं? Whatever is the keyword, we start with the first keyword. हम उस matrix में लिखते हैं from left to right, from top to bottom. Whenever it is being exhausted, keywords are going to exhausted. Then right from the beginning of A to Z, we fill rest of the blocks of the matrix. And how it is being done? Let us see. Suppose that our keyword is a Playfair example. Suppose Playfair example is the keyword, then 5 by 5 matrix can be framed by this keyword as the following. Now the first character of the keyword is P. First character of the keyword is P. So first place we have written P. Second one is L, so we will writing L. Then A, we will write A. From left to right, then Y, so we will write Y. Then F, we will write F. F again, after F there is A. Now A we have already filled, so we will leave the duplicate. So A is not considered. Then we have a I, so we have written here I. Now since I is written, so I and J will be using the same block. After I it is R, so we have written R. Then we have E, then we have X, then we have again A. But this A is already being used, so we will leave that. So we will come with M, then B, then we have B. Now, after M, we have P. P we have already filled. P we have already filled, so we will not consider that. L we have already filled. E we have already filled. So it means the keywords has been exhausted. So since keyword has been exhausted up to M, so what we will do, we still remain the 15 blocks unfilled. So what we will do, we will start from A to Z. Since A is already being used, so we will start with B, C, D. We will try to fill only those alphabets which are not being used, H, A, N, O, Q, and so on. So in this way, the matrix is being created for the Playfair example. Suppose the Playfair example is the keyword. Now if I say Sudhir is the keyword, so then in that case the first will be S, then U, then D, then H, then I, then R, and Sudhir keyword is finished. It is exhausted. So we will start with A, B, C, and so on, and we'll try to fill from A to Z, leaving the duplicate values which we have already filled. So that is how the matrix is being created. Now after the matrix is created, the encryption, second step is the encryption process. So how this encryption process goes on, we have 5 steps of doing the encryption process. We have to understand it very carefully, we have to learn it very carefully, and then once you are able to learn the process step by step, you will feel very happy, and it will be very easy to adopt the Playfair cipher technique to convert the plain text into a ciphertext. Now before executing these steps, first of all, the plain text message that we want to encrypt needs to be broken down into groups of 2 alphabets. For example, if our message is my name is Atul, it will be broken into groups of 2 alphabets. So how it will be broken? M-Y, N-A, M-E, I-S, A-T, U-L. And then the encryption process works on this broken down the message. Now, if both the alphabets are same or only one is left, whenever we are breaking the total text character into a group of 2 alphabet, there is a possibility that 2 characters which are coming are same. For example, if you take an example of good, G-O-O-D, you good, you are good. So good may, if both O is coming all together, then in that particular case, one is left, one is discarded, and we replace that discarded letter by the X after the first alphabet. So if it is OO, so OO will be replaced by OX, and then encrypt the new pair and then continue. If both, one more thing, if here the number of characters present in this particular message is even, So if you are breaking into two alphabet group, though you will be getting all. But if the number of characters available in the plain text message is odd, then it may be possible that you will be in the last you will be getting only one character. So if it is one character, you add X after that character so that it will become a two alphabet group. So that is why second point is very important. Now third point is if both the alphabet in the pair appear. Now the encryption process. This is the pre-encryption process. First and second point is pre-encryption process, and the third point is the encryption. First step of the encryption process. If both the alphabets in the pair appear in the same row of our matrix, replace them with the alphabets of their immediate right respectively. If the original pair is on the right side of the row, then wrapping around to the left side of the row happens. Now let us take an example of that. We have to be very cautious about learning this process. If both the alphabets in the pair appears in the same row of the matrix, we will replace them with the alphabet of their immediate right respectively. And how it is being done? Let us see. See, we have to replace my. So where my is, we have my. Now, let us take an example which suits it. ME. Let us take an example ME. Now, ME is in the same row. See, this is the row in which M and E exist. So, what does say? It says if both the messages, just wait. If both the alphabets in the pair appears in the same row of our matrix, replace them with the alphabet to their immediately right respectively. Now what does it mean? M and E is lying in the same row. So M will be replaced by the next character. Now the next character, there is no next character after M. So what we'll do, we will wrap it down. हम इसको wrap कर देंगे. So M will be replaced by I. M will be replaced by I by wrapping it. And E will be replaced by X. So that is why M has been replaced by I and X. See. Now, this is the condition when the pair which we have made of the two alphabets, if they lies in the same row, the replacement which we used to do is the immediate right, and immediate right is finished, then we wrap around to the left side. If both the alphabets in the pair appear in the same column of our matrix, replace them with the alphabet immediately below them respectively. If both the alphabets in the pair appear in the same column, replace them with the alphabets immediately below them respectively, and the same wrapping phenomena is being conducted. Let us take an example. Which one is just wait. UL. Let us take an example of UL. Where the UL is? U and L is lying in the same row. Here is the U and here is the L. So here, so it is lying in the same column. So when it is lying in the same column, U will be replaced by wrapping down the line. U के बाद कोई character नहीं, so it will be replaced by L, and L will be replaced by R. So UL will be replaced by L and R. Okay. Now, third one. The next one. If the alphabets are not in the same row or column, replace them with the alphabet in the same row respectively, but at the other pair of corners of the rectangle defined by the original pair. Let us understand it one more time. If the alphabet are not in the same row and the column, it means they are lying in the different row and the different column. Then what does it mean? Replace them with the alphabet in the same row respectively, but at the other pair of corners of the rectangle defined by the original pair. Now let us take an example. Suppose I take an example my. Let us take an example of my. The first one, my. So where m and y is, so whenever we find m is in the fifth column and y is in the fourth column, m is in the second row and y is in the first row. So it means different row and different column. So if different row, different column, so what we will do, we'll try to frame a rectangle like this. And my will be replaced by the left corner element, same row but the corner element. So this rectangle का जो corner है, that is x. So m will be replaced by x and y will be replaced by f, by the corner element. Same row but the corner element. Let us take another example. Let us take an example of NA. Where is N? N is here and A is here. Different row, different column. So what we will do, we will frame a rectangle. In this rectangle, N will be replaced by rectangle, same row but the corner element of the rectangle. And A will be replaced by same row but the rectangle element, that corner element of the rectangle, that is L. So N will be replaced by O and A will be replaced by L. Let us take another example. IS. Where is I? I is here. And where is S? S is here. So what we will do? We will frame a rectangle. This rectangle will be like this. This rectangle. So I will be replaced by the same row element but the corner of the rectangle, that is M. And S will be replaced by same row element but corner element, that is K. Let us take another example. AT. A is here and T is here. T yahan hai. So what we will do, we will first make a rectangle, AT. So A will be replaced by P, corner element but the same row, and T will be replaced by V, corner element the same row. So that is why you will find that my my will be replaced by xf, na will be replaced by ol, me is replaced by ix, is will be replaced by mk, at will be replaced by pv, and ul will be replaced by lr. So that is how this Playfair cipher used to work, in which first we create the matrix. There is a process by which we are filling the matrix, and then after filling the matrix we try to do the encryption, first pre-encryption process and then the encryption process. So this seems to be very simple, very mathematical and very easy method to implement. The next one is the Hill cipher. This Hill cipher works on the multiple letters at the same time. It also uses the matrix theory, but the limitation of the Hill cipher is that it is applicable to the small messages only. So how this Hill cipher, the name has been given Hill cipher just because of the person who has invented this. The name has been given as Hill cipher. Now this is the algorithm of using the Hill cipher. Now what it says that treat every letter in the plain text message as a number, because A will be considered as 0, B will be 1, and Z will be 25. The plain text message is organized in a matrix form based on the above conversion. For example, if our plain text matter is CAT, based on the above step, we replace C by 2, A by 0, and T by 19. Therefore, our plain text matrix will look like 2, 0, and 19. Now, our plain text matrix is multiplied by a matrix of randomly chosen keys, and this key matrix consists of n into n, where n is the number of rows in our plain text matrix. So there are 3 rows, so we will consider the matrix 3 cross 3. So for example, I have taken now this is called key matrix. Now this key matrix varies from person to person, user to user, and but the sender and the receiver must be knowing the same key matrix, because if this matrix is being used for encryption process, the same key will be used for the decryption process. Now what we'll do after taking the the matrix, which is the matrix of the plain text, and then the key matrix, we multiply these two matrices and we get the result. Of course, the result which we are getting is 31, 216 and 325, which is more than 26. So we are not able to convert 31, 216 and 325 back into the ciphertext. So what we will do, we take the mod value of mod 26 of these three values, so that it will become 5813. And whenever it will become 5813, because when take 31 mod 26, it will be 5, 216 mod 26, it will be 8, 325 mod 26, it will be 13. So by the same process, A is equal to 0, B is equal to 1, we can change B is equal to, B means F, 8 means I, and 13 means N. So our plain text message was cat, but the plain text message was cat, but after doing this matrix multiplication, the ciphertext become fin. Now this fin, instead of cat, the sender has sent fin to the other side. Whenever fin is being received, it is actually received by the receiver. So the receiver will be using 5813, the code of FIN. But if he does not know, if the receiver does not know this key matrix, that is why it is very important. If the receiver is not know this key matrix, then he will not able to get cat from the fin. So what he will do the reverse process. We have multiplied the plain text matrix with the key matrix, and after receiving the ciphertext matrix, we have to multiply this ciphertext matrix by the inverse of this matrix, then only we will be getting the value. So for decryption, what we will do, we will take the inverse of this matrix and then multiply it by 5813, and whatever value we will be getting, that will be equal to 2019, and 2019 will be showing that it is a cat. So the important part is not the algorithm, because algorithm is known to each and everyone. The important part of this, of any encryption process or the decryption process, is the key. So that is why this key is very important. If key is not known, this key is not known, if this key is not known, then it will be very difficult for the receiver to find out the original message. That's all from this side.